Hi, today we're going to talk about lesson 7, scales. Scales are the measurement marks placed at like precise intervals on scientific equipment. So those little markings and numbers that you have in anything that you use to measure something. In scientific research, scales are essential to get precise results. Because if not, how would you measure things? If you measure it like with a hand or a foot, it's not the same. It has like different measures for everyone, so you need a standard. For the vocabulary today, we have accuracy, exactitude, an indication of how close a measurement is to the correct result. Like as you see here, this one, it's accurate. It's the same for the weight that what you read, that you know that it's true from what you weigh. And then inaccurate, it means that it's not exact. Gradation, it means the scale markings that denote equal units of measures. And then precision, that degree to which measurements can be replicated. It means that when I measure something over and over and over, it should be really similar, not really different. If it's really different, it's not precise. And then precision in measurements. By the way you record a measurement, you can tell others about the precision of the instrument you are using. For example, in a ruler, okay, the smallest graduations here are the millimeter markings, and it means that you can measure precisely down to the millimeter level. When using a calibrated scale, you should estimate one digit beyond the level of the markings. Okay, so this means that if you are measuring millimeters, you would have to measure like 1.1 millimeter extra. And then if you're recording your measurement in centimeters, you should estimate 1.1, 0.10 centimeters or 2 decimal places. And you're gonna see this like with examples better. But here I have an example of lines, and you can see that this line is somewhere between 2.1 and 2.2 or 2.20 to 2.10. So it's not exact, but we know that it's somewhere in there, okay? So any number between those, like 2.13, 2.17, it would be correct. And then if the line is exact, like falling right into number 2, like this example, then you would have to say that it measures 2.00. You would need 2 decimals because we're talking about centimeters. And then for accuracy, in everyday language, the terms precision and accuracy, we change them all the time, but in science, they have different meanings. Accuracy is how close your result is to the accepted value for a given measurement. So if I measure something that I know that it weighed 100 grams, it should say 100 grams on the scale, but if it doesn't, it's not accurate. And then there are many reasons that accuracy it's not working in an experiment or we're reading an instrument. You can make a mistake, human error, and then that's why you have to like do it many times to make sure that you're not making a mistake. And then the other, it's an instrument error. So it's the instrument, it's not working in the right way. And then the third common error, it's method. What happens if you are making an experiment, taking measurements, and then you're using a different method than your partner or a different instrument, then you're not gonna get something accurate, okay? And that would be it for the lesson of today.